Yesterday we looked at the double angle results. Now we're going to look at the t results, which you can think of as the half angle results. A little bit different to what we saw yesterday though. So we're going to let t, just the pronumeral t, represent the tan of the half angle. So theta on 2. Now using the double angle result from yesterday, so theta is double a half theta, we saw that tan 2 theta was 2 tan theta on 1 minus tan squared theta. So for tan theta, the half angle becomes theta on 2, so we get 2 tan theta on 2, 1 minus t squared theta on 2. But now we can just simply use a pronumeral to represent that, and we just get 2t on 1 minus t squared. I now draw up a triangle. So opposite over adjacent is 2t on 1 minus t squared. I can do a bit of Pythagoras, and we end up working out the hypotenuse. Where are we? There we go. The hypotenuse must be 1 plus t squared. So the adjacent is 1 minus t squared, the hypotenuse is 1 plus t squared. And so from that we can create t results for the other ratios. So if t is tan theta on 2, okay, tan theta is going to be 2t on 1 minus t squared. Sine theta, opposite over hypotenuse, will be 2t on 1 plus t squared. And cos theta will be 1 minus t squared on 1 plus t squared. But as I say, these could be thought of as half angle results. So yes, that's tan theta, but if we were to say t is tan theta instead of tan theta on 2, then tan 2 theta would be 2t on 1 minus t squared. And if I was to say t was tan 2 theta, then tan 4 theta would be 2t on 1 minus t squared. So basically half angles, double angles. Let's use it. We're going to show that 1 minus cos x on sin x is t. Now of course they need to define what t is, otherwise it wouldn't make sense. So t is, yes, tan of half the angle. So I can substitute in my t results for cos x and sin x because x is double x on 2. So I've got the half angle and the double angle there. Yes, I can use my t results. Subbing in. Well, fraction on fraction we don't like. Let's multiply everything by 1 plus t squared, and we get 1 plus t squared minus 1 minus t squared over 2t. Tidying that up, 2t squared on 2t cancels, and yes indeed we end up with t. We're going to use the t result here, so t is tan theta on 2, to simplify this expression. Well, if I let t represent tan 75, and then I can turn that expression into a t result. So theta on 2, as far as I'm concerned, is 75, which means theta, double that, is 150 degrees. So we've got 2 tan 75 on 1 plus t squared, which is 2t on 1 plus t squared, but that's the t result for sine theta. Theta, we're saying, is 150 degrees. Sine of 150, we're in the second quadrant. The acute angle would be 30 degrees. Sine of 30 is a half. Now we're going to prove this. 1 plus sine theta minus cos theta over 1 plus sine theta plus cos theta is tan theta on 2. It's all right. I'll let t be tan theta on 2. So essentially, I want to show the left-hand side is t. Substitute in the t results, and again the denominator, they're all 1 plus t squared, so let's multiply everything by 1 plus t squared, get rid of that fraction on fraction problem, and this is what we get. So let's play around with that. I've got 2t squared plus 2t over 2 plus 2t. There's got to be some cancelling happens there. Oh yes, top factorises, we get 2t outside of t plus 1. Bottom factorises, we get 2 outside of 1 plus t. Well, 1 plus t and t plus 1, that's the same thing. That'll cancel, the 2's will cancel, and we get t. But this question, I don't leave it like that because they haven't said show it's equal to t. T was something I introduced. So now I can say, oh yeah, but t, that's what I said was tan theta on 2. So yes, I've proven what they want me to. Here's an HSC one. And they've told us use the t result substitution. They do give us the option of, if you want to, go another way, that's fine. But usually when you see these hence or otherwise, it's better to go with the hence because they're pretty much just giving you a big hint. This is going to be the easiest way of doing it. Show that cosec plus cot is cot theta on 2. Okay, cosec plus cot. Well, they're the reciprocal of sine and tan. So I'll put the t results in, but turn them upside down. Now nicely, the denominator ends up to be 2t for both. I can add those fractions together. I get 2 on 2t, 2's cancel, 1 over t. So it's the reciprocal of t, well that's cot, because t was tan theta on 2, the reciprocal of tan is cotan. So 17F will now play with our half angle results, or T results as they're called.